Hey gang, alright, check this out. We're going to work on a fifth root problem. So index 5 to the radical. So the index root or the principal root is 5. And our radicand is going to be 72 in parentheses. And then just outside that, we're going to take it to the power of 4. Okay, so I'm going to let you write that down. Take a look at that. Think about your rules for exponents, rules for radicals. See what you come up with. Okay, before we go much further, we're going to mention something about this radicand. We have 72 in parentheses, right? And remember, parentheses says we need to treat whatever value is inside as a single value, as though this is a single number, basically. Now, 72, that's easy to do, but sometimes it could be a polynomial, it could be a basic addition problem, it could be anything, right? And in those cases, we still need to treat it as a single value. In other words, this exponent of 4 is applied to whatever's in the parentheses, okay? So that's important to remember. So I asked you to think about rules for radicals, rules for exponents. I'm going to put something here on the board. So we have a to the power of n over m, okay? So it's a rational exponent right there. And side note here, rational exponent, right? Makes it easy to remember, because remember, a fraction is a ratio. Okay, so how can we rewrite this a to n over m? Keep a to the power of n, right? And this m is going to become the index root. Okay, that's probably a little hard to see, so I'll rewrite it over here. So a to the n over m is equal to the m root of a to the n. Okay? So this is the important bit that we want to look at. Alright? So we can rewrite this problem right here, this radical, we can rewrite it as 72 stays in parentheses, right? To the power of 4 over 5, right? And what we're following is the same rule, a to the n over m is equal to the m root of a to the n, right? We're applying the same rule, where a would be equal to 72, right, in parentheses, right? M would be equal to 5, right? And then n would be equal to 4. Okay? So we see how we can just plug and chug. Okay, so can we factor out anything in the parentheses here? We see a 72, so we can easily say that that is 8 times 9, right? Remember, data is like energy. It's neither created nor destroyed. It just changes form. So we're factoring out those the number 72 into its factors or parts, right? So we have 8 times 9, right? So 8's a factor, 9's a factor. You still have to take it to the power of 4/5, right? So now we're going to come just down here on the board if you want to follow along. Can we factor out 8 times 9, which is in the parentheses here, right? And remember, this is the original radicand. It's still equal to the original radicand right here, okay? So can we factor out 8 times 9? We could take it to 2 cubed multiplied by 9 to the power of 4/5, right? Can we take it any further? We had 2 cubed times 9. Can 9 be factored? Sure, we can make that 3 squared, right? Now, remember, this value right here is the same as the original radicand, right? 72 to the 4th, 4 over 5 to the power of 4/5 is the same value as this radicand right here, because it's the 5th root of 72 to the 4th. That is equal to 2 cubed times 3 to the 2nd to the power of 4/5, right? Okay, so we want to keep that in mind, that we haven't changed anything in terms of its value. All we've done is factored it out and rewritten it as we reduce through the radical. Okay? Alright, so now we're going to rewrite again, but we're going to apply that original exponent, because remember, that was the 4th root, right? Or excuse me, that was the... Okay, so now what we're going to do is we're going to apply that 4th power right here, because, right, it was the power of 4 applied to 72. So we're going to apply that 4th power right here. And because it's outside the parentheses, we have to multiply it against the exponents, right? So we see 4 to the 8, 4 times 2, right? This exponent is going to multiply against this exponent, right? So it's going to be 3 to the 8th, right? have this 4 against that 3. That's going to be 2 to the 12th. Right? And then we can't forget the index, which is right here in the denominator position of the exponent, and that was 5. So our final solution, as we reduce and factor out the radical, we get 2 to the power of 12 over 5 times 3 to the power of 8 over 5. Alright, cheers.